All right, in this video we're going to go through the solutions for the fourth test you're having, which is on the quadratic formula. If you haven't noticed already, this one is slightly longer, so 45 minutes, and you're not allowed to use a calculator or have any notes. But you will have these key ideas. So you've got the quadratic formula. Do note that this is the same as what you've been using. It's just the plus and the minus has been separated into two. So you should be using negative b plus or minus the square root of b squared minus 4ac over 2a. It's exactly the same thing, it's just split into two. So when you see this, you're going to save time writing it this way as opposed to separately. And the determinant, the discriminant as well. So remember the discriminant and what that is used for. So the discriminant, we say, is the represent using the triangle. So when your discriminant is less than 0, you have no x-intercepts. When your discriminant is equal to 0, you have one x-intercept. And when your discriminant is greater than 0, you have two x-intercepts. So you need to remember that as well. All right, let's move into the solutions because this might be a long video. All right, so for a particular quadratic with a turning point at 2, 4, the discriminant is equal to 2. Which of the following statements is false? Now, this is quite a tricky question to start off with. So let's just say, all right, if I was to draw this, what would it look like? So we know we've got a turning point. Well, that's a terrible circle. At 2, 4. So let's say that is 2, and there's 4. So there's your turning point. Now, you haven't been given any other information about any intercepts or any other points, but you know your discriminant is equal to 2. So if it's equal to 2, it means, obviously, it's greater than 0. Therefore, you have two x-intercepts. So your graph, it doesn't matter where it's actually crossing the x-axis. I know it has two x-intercepts. So this is what it would look like. Now we need to know which one is false. So let's go through each option separately. The graph of the quadratic has two x-intercepts. Okay, so that's true. So we'll cross that one out. So we're looking for the one that is false. The turning point is a local maximum. So this is up the top, so it's a local maximum. So that's also true. Cross that one out. The turning point is a local minimum. So you can't have both a maximum and a minimum. So obviously this one is false. And let's just check D. The graph of the quadratic crosses the x-axis. Well, it does, so that's correct, which is true. So it means leaving only C as the only false option. Just a little hint before we move on. If I read this question, I would say, well, you can't have it both a maximum and a minimum. So it's either one of these two. Okay, so in multiple choice questions, if you have no idea what the question is asking you, you can look at your choices to make, increase the probability of guessing it correctly. So you can't have both a maximum and a minimum. So if you had to guess between the two of them, you're increasing your probability to 50% as opposed to just 25%. All right, let's move on to question 2. For the quadratic equation y equals 2x plus 1 times 3x minus 1, the value of the discriminant is equal to. So for this one, you can't find the discriminant until you've expanded this. So let's expand it first. So 2x times 3x plus 2x times negative 1 plus 1 times 3x plus 1 times negative 1. So I don't know why I've done that. I would have said x and I wrote 6. Okay, let's just put the x there. So 3x times 2x is 6x squared. 2x times negative 1 is negative 2x. 1 times 3x is 3x and minus 1. So let's just tidy that up. Whoops, let's just delete that for a bit. Okay, so now we can actually find the discriminant. So let's let A equal 6, B equal 1, and C equals negative 1. So your discriminant is equal to B squared minus, sorry, I pressed the button, minus 4ac. So we've got 1 squared minus, try to get into the habit of writing this in brackets, 6 times -1. And I feel like I've made an error somewhere. Oh no, it's all good. It's horrible when you know the answer and you're just thinking, I've done a mistake. There we go. So it's 25. All right, so for this one here, if you wanted to, I don't think you could do much else other than actually solving it. I can't think of any way of doing it other than solving it. When I say that, I mean guessing what the answer might be. All right, question 3. The equation 3x squared plus bx plus 12 has one x-intercept. The possible value or values of b is equal to. So first of all, your discriminant is equal to b squared minus 4ac. Now, if you have just one x-intercept, that means your discriminant has to be 0. Okay, so remember, one x-intercept discriminant is equal to 0. We have b squared minus 4 times 3 times 12. And so we've got here 4 times 3 is 12, 12 times 12 is 144. So that means we've got b squared equals 144. When we take the square root of b squared, we must also take the square root of 144. And therefore we have plus or minus 12 as a solution. So your answer there is B. Quite a tricky question. You'll notice a lot of these questions are quite tricky, but understanding how the discriminant relates. So if you had two x-intercepts, you would say the discriminant has to be greater than 0, and then if there was no x-intercepts, it would have to be less than 0. Okay, moving on to question 4. Which one of the following parabolas has the graph of y equals -2x squared minus 3x plus 5? Okay, so straight away I would say this is a negative parabola because the coefficient in front of coefficient of x squared is a negative number. So A, B are the only negative graphs. So C and D are both positive. That's good because I can only show 2 at a time. So even if I had to guess, I know I've got a 50% chance of guessing it correctly. But let's actually do it. So actually I'm not going to have much space here either. Now I told you the other day the turning point is -b over 2a. I would actually use this because you can see they've got different turning points. You could go on and do the quadratic formula, which is, I think, my solution. I know I didn't do it this way on my solution sheet, but on my solution sheet, I think I did the quadratic formula. But this is, also useful. So -b, so we have -3, because b is -3 over 2 times -2. Well, this is tricky. All these negatives can might make you make a mistake. So we have +3 here. 2 times 2 is 4, and we end up with a negative. So -3/4. This one you can see is a positive x. So we've got what we worked out here was the x coordinate of the turning point. So that one's clearly positive, and this one here is clearly negative. And you can see that this one's 3/4 and this one's -3/4. You can just see it's just before 1. So I know I haven't made an error. If I had something like x equals 6, I know I've probably made a mistake somewhere along the line. Now you can do the quadratic formula if you want. I'm not going to do it, but when you do, you will notice that this is basically the reflection of this one. So it's really important that you actually don't make any errors when you do it. Otherwise, you're going to, and that's where the negatives come in tricky. Yeah, the negatives might get you. All right, now moving on to short answer. First of all, we've got to calculate the discriminant, interpret what it tells us about the parabola, so how many x-intercepts it has. Okay, so over here I'm just going to identify A, B, and C. And remember your discriminant, I'm just going to write it up here, otherwise I'm going to run out of room on the sheet. So b squared minus 4ac. So here we have -1 squared See how I put it in brackets? It's just to remind you that when you square a negative number, you get a positive answer. All right, -4 times 2 times 3. Didn't bother putting any brackets there because there's no negatives, but you can if you want. 4 times 2 is 8. 8 times 3 is 24. So your discriminant is equal to -23. Remember, when it's less than 0, there are no x-intercepts. All right, the next one. A equals -4, B equals 2, C equals 1. So let's plug that in. So we have 2 squared minus, I'm going to use brackets here because A is a negative number. So 2 squared is 4. 4 times -4 is -16 times 1. So 4 plus 16 is 20. So we have 2 x-intercepts. And A is equal to 2, B is equal to -4, C is equal to 8. Okay, plug that in. Again, we've got a negative, so I'm going to put it in brackets just so we remember not to. And then I've just already done brackets here as well. Okay, 16 minus 2 times 4 is 8. 8 times 8 is 64. So that is 48, -48. Oh, I think I got the different answer on my actual form. Anyway, no x-intercepts. I'm rushing this, so I don't think I've made an error, but you know, I usually make at least one mistake when I do these. Anyway, sketch each of the following quadratics and clearly label the exact coordinates of any axis, intercepts, and the turning point. So this has been given to you. The square root of 2 is approximately 1.4. So that means somewhere in question 2, you're probably going to see the square root of 2. And so if you do question 2 and you don't come across the square root of 2, you probably made a mistake. So why would I give you this if you weren't going to use it? All right, so for question A, I'm just going to use the quadratic formula. So I might scroll down a bit so we can see a bit more of the graph. Okay, so when you use the quadratic formula, just identify A, B, and C. And I'm going to write out the quadratic formula. Remember, it is on your sheet, so you don't have to, stay up all night trying to remember it. Connor, can you turn it down? Sorry, my son likes to listen to very loud music. Okay, so now the B is negative, and here we've got a negative, so that makes it a positive. So tricky, tricky. Okay, -4 squared is 16. -4 times 2 is 8. 8 times 1, so it's -8. I feel like I made it. No, I think that's all good. 2 times A is 4. I'm skipping steps here only because I'm going to run out of space if I don't. Okay, so I've got 4 plus or minus √8 over 4. So square root of 8 simplifies to 2 √2. And I'm running out of room. Let's see if I can squeeze it in over here. So that means I have x is equal to 4 on 4. See how I'm separating the fraction? So 4 on 4 is 1. Oh, I could have done minus there. And then that's √2 on 2. And then we also have 1 minus √2 on 2. So effectively, we've got 1. I might do it over here, I'm running out of space. So 1 plus √2, which we know is 1.4 divided by 2 is 0.7. So I've got 1.7. And then 1 minus 0.7 is 0.3. Okay, so 1.7, 0.3. Your y-intercept is at 7. Oh, it's not 7, sorry, 1. And then you also have to do your turning point. Oh, I'm running out of space here, aren't I? So your turning point, I'm going to have to get rid of all that stuff over there. I'm sorry. Okay, so let's just draw on here 0.3, 1.7, and 1. Okay, so your turning point formula is negative b over 2a. So we have 4 over 4, which is 1. So then that's your x coordinate. So your y coordinate, just substitute 1 in. So we're going to have 2 minus 4 plus 1. So I've just substitute 1 in here for x. So 2 minus 4 is negative 2 plus, and I've made a mistake somewhere, haven't I? Because it shouldn't be. Hold on a sec. I'm going to have to pause because I've made a mistake somewhere. Just give me a sec. Okay, so if you didn't pick it up already, I put that in the wrong spot. Silly me. Now, the reason I knew I made a mistake is because my intercepts weren't in the right spot for a positive graph. Okay, so I know this graph has to look like that, and my graph wasn't, if I joined the dots, it wasn't going to look like that. So that's how I knew I was making a mistake along the way. And now this will work. So 2 minus 4 is negative 2 plus 1 is negative 1. And that makes sense because there it is there. Okay, and remember this is symmetrical. So this point can go here. And then you've got a nice little parabola. Oops, didn't really go through those points too well. Ah, what a terrible parabola. But let's label it. We have 1, negative 1. This point here, should write the exact value. So 1 plus root 2 on 2, and this one here was 1 minus root 2 on 2, and that one was 1. Okay, let's move on to the next one. So I'm just going to see what we've got. Okay, so this is the last one to do. All right, so this one here is a negative parabola. Okay, so I know, remember what I was saying, when you join the dots, it should look something like this. So if it doesn't, then you know you've made a mistake somewhere along the line. This one here, I'm just thinking off the top of my head whether we can use factorizing as opposed to the quadratic formula. I don't think we can because I'm pretty sure the answer's got a root 2 in it somewhere along the line. Okay, so let's just use it using the quadratic, solve it using the quadratic formula. Okay, c equals negative 1. I'm not going to write the quadratic formula out just because I'm not going to have enough room. So let's test my memory. B squared, 36. 4 minus 4, okay, over negative 2. So we have, let's just tidy that up. So this is the square root of 32, which comes out to be 4 root 2. And remember, separate it. So we've got negative 6 on negative 2. And then, oh, sorry, minus 4. Oh, sorry. I'm thinking ahead of myself and trying to make sure I'm doing it correctly. So that should be a plus. Oh, these negatives are playing havoc with my mind. Sorry, I'm just thinking. Okay, so 3 plus, well, one's going to be plus and one's going to be minus anyway. What am I doing? So I'm not concentrating. There should be a 2 in there. And then the other one is 3 plus 2 root 2. Sorry, let's go back here and actually, I've confused you. There we go. That's where we got the 3 from. The 4 root 2 on negative 2. So the 4 and the 2 cancels out to give you the 2. Okay, so that's where the 2 has come from, the 2 root 2. And before we know, in the question it said square root of 2 is 1.4. So if we just go up here and do that, so 3 minus 2 times 1.4, 3 minus 2.8. I think I've got a different answer on my solutions. Oh, this is where I need to check my answers. And then 3 plus 2.8 is 5.8. All right, I'm just going to pause again just to make sure I haven't made any errors. All right, I've noticed I've made an error here. So hopefully you're sitting there thinking, I know what it is, miss. But there was an error also. If we just go to the solutions that I've already uploaded, yeah, I made a mistake here with my negative. So see how I got a negative here and then that negative disappeared. So the solutions for this one are wrong, which is a shame because now I'm going to have to go back and fix it. And I also checked it on the calculator. So just to show you what I did while you're on pause, although you have no idea because you didn't have to wait. So I got the exact value, if you can see under the writing there, and then the approximate value. Okay, so I'm doing the solution right here, but the scan solutions are wrong at this point in time. So hopefully I can fix them soon. Okay, so 0.2, come on, 0.2 and 5.8 approximately. Okay, so remember this is the purpose of just graphing it to make sure that we're actually putting it in the right spot. When you label your graph, you should always put it in an exact value unless the question asks for you to do it otherwise. All right, let's find our turning point. I might do that over here. So your turning point is at x equals -6 over -2, so that's 3. So you can see that is halfway. And then the y is going to be -9 plus 18 minus 1. So 9, 8, 3, 8. I wonder what I did on the previous one. So I would have got -3 on the other one. Can I just go back and see what I've done? Oh, I got 7. Oh, I must have made a mistake. So I even wrote 3. Where's my working out? I got 3. Isn't that funny? I didn't even question it back then. And what did I do wrong here? -9 plus 18 is 9, minus 1 is 7. Oh gosh, I've made another mistake there. Okay, it's all good. At least I'm doing it right on the video. For those of you who are watching the video, you'll... and then the y-intercept there is there at -1. So remember, whatever your constant is here. Yeah, so you guys know that you're at an advantage because you're getting the correct answer. But those who aren't watching it will have no idea. Okay, so I'll go back and fix that anyway. Oh, no, no, that's right, 3, 8. I thought I drew it incorrectly. All right, so 3, 8, this point here is 3 plus 2 root 2. And this one here is 3 minus 2 root 2. And that point there is -1. Tricky, huh? Okay, so please make sure you understand this is probably the hardest out of the 4 of them. But it's just a matter of taking your time. You do have 45 minutes, so you can see there I've done it in 23 minutes, although I do know what I'm doing, but you know, I'm talking to you at the same time, and so I am taking my time. So in 45 minutes, it should be enough time to get it done and have time to reflect on it afterwards. All right, girls, bye-bye.